Hello, my name is Eldrin Lee, and I'll be speaking today about the evolution and capabilities of modern JavaScript. JavaScript is one of the core technologies of the web, working hand in hand with HTML and CSS. It began in 1995 as a very simple scripting language meant to add small bits of interactivity to web pages, like button clicks and pop-ups. Today, JavaScript has transformed into one of the most powerful and adaptable programming languages in the world. It runs not just inside web browsers, but across servers and even in applications we use every day. What makes JavaScript so successful is its ability to evolve quickly as technology changes. The language has grown alongside the internet itself, gaining new features, new performance improvements, and support from a global community of developers. JavaScript was created in 1995 by Brendan Eich while working at Netscape. Amazingly, he designed the first version of the language in just 10 days. It was called Mocha, then LiveScript, before finally becoming JavaScript. That name was largely a marketing choice, aiming to benefit from Java's rise in popularity at the time. Even in its early form, JavaScript served an important purpose. It allowed websites to become more dynamic, letting web pages respond to user actions instead of staying completely static. Despite its potential, early JavaScript had many weaknesses. It was slow, it lacked proper debugging support, and browsers often interpreted it differently. This meant code that worked perfectly in one browser could completely fail in another, leading to frustration for developers. Because of these limitations, JavaScript was mostly used for small enhancements like form validation or simple animations. It wasn't yet seen as a tool for building full-fledged applications. As websites became more ambitious and complex, developers needed better tools to manage large code bases. Frameworks like Angular, React, and Vue were created to solve that problem. They introduced component-based design, where different parts of an application could be built as reusable modules. These frameworks help JavaScript scale into full client-side applications, powering social networks, online shops, and professional tools that run smoothly right inside the browser. One major impact was the rise of single-page applications, or SPAs, where the entire site loads once and updates dynamically as users interact with it. SPAs improve speed, responsiveness, and overall user experience by reducing full-page reloads and making web apps feel much more like native applications. These frameworks also brought new ways to manage state and data flow efficiently, making it easier to build interactive and dynamic user interfaces. With virtual DOMs in React and reactive data binding in Vue and Angular, developers could update only the parts of the web page that changed, improving performance and maintainability. Moreover, the ecosystem around these frameworks, including libraries, tooling, and developer communities, allowed teams to adopt best practices, test more efficiently, and maintain large projects over time. This evolution made modern web development faster, more reliable, and accessible to a broader range of developers, turning JavaScript into the backbone of today's web application. A huge milestone arrived in 2009 with the release of Node.js. For the first time, JavaScript could run outside the browser and operate on servers using the Chrome V8 engine. This meant developers could build full-stack applications using one single language. Node.js quickly became popular because it is fast, lightweight, and excellent at handling real-time tasks like chat systems and streaming services. It turned JavaScript into a true multi-purpose language used across the entire technology stack. This transformation was made possible by Google's V8 JavaScript engine, the same engine that powers Chrome. V8 compiles JavaScript directly into machine code, making it extremely fast and efficient. By integrating V8 into Node.js, developers could now execute JavaScript on servers with performance close to compiled languages. This breakthrough redefined what JavaScript could do, enabling large-scale backend systems, APIs, and even desktop applications through frameworks like Electron. Beyond opening JavaScript to the server, Node.js is introduced to an event-driven, non-blocking I/O model that made it highly scalable for handling many connections at once. It also allowed developers to build APIs, microservices, and real-time applications much more efficiently than traditional server technologies. With features like the built-in FS module for file handling, HTTP server capabilities, and a vast ecosystem through NPM, Node.js became a backbone for modern web development, enabling startups and large companies alike to build fast, maintainable, and full-featured applications entirely in JavaScript. Let's pause and think for a moment. With all these innovations that we've seen, what can JavaScript actually do today, and how has it shaped the software that we use every day? I'll give you a minute to discuss. To sum it up, let's take a step back and really think about what JavaScript can do today. At its core, JavaScript started as a simple language for adding interactivity to websites, but now it powers everything from complex web applications to server-side services. On the front end, frameworks like React, Angular, and Vue have completely transformed how developers build user interfaces. They allow us to create dynamic, responsive applications that almost feel like desktop software, and they make managing large, complex code bases much more structured and maintainable. On the back end, Node.js brought JavaScript to the server. This was a game changer because suddenly developers could use the same language for both client and server code. With Node.js, we can handle high volumes of concurrent requests efficiently, building APIs quickly, and even implement real-time features like chat apps or live notifications. This unification of language across the stack has streamlined development workflows to make it easier for teams to collaborate. When it comes to user experience, JavaScript has driven several major innovations. Single-page applications provide instant navigation without full-page reloads. Progressive web apps allow web applications to behave like native apps, including offline functionality and push notifications. Real-time updates with WebSockets or libraries like Socket.io create interactive live experiences from collaborative editing to live dashboards. On top of that, rich visualizations with libraries like D3.js, interactive media, and sophisticated animation frameworks have made interfaces more engaging and intuitive than ever. JavaScript is behind almost every modern enhancement that makes software feel fast, responsive, and immersive. The rise of JavaScript as a universal language revolutionized the software industry and completely reshaped how software teams and enterprises operate. Full-stack JavaScript development means smaller, more versatile teams can handle both the front-end and back-end development. Enterprises can standardize their tech stack, reduce context switching, and accelerate development cycles. In many ways, JavaScript isn't just a tool, it's become a foundation for modern software engineering practices, shaping how we design, build, and scale applications today. JavaScript has moved far beyond its origins in the browser. React Native enables developers to create native mobile apps for both Android and iOS. Electron powers desktop applications such as VS Code and Slack using JavaScript and web technologies. The language is even used in specialized fields like artificial intelligence through TensorFlow and in 3D web graphics using Three.js. This growth shows how JavaScript has expanded into almost every corner of modern computing. The language continues to evolve rapidly. TypeScript, which adds static type checking to JavaScript, is increasingly used in professional development because it reduces errors and improves maintainability. Another rising area is WebAssembly, which works alongside JavaScript to enable high-performance features such as gaming and video processing in the browser. Serverless computing, supported by services like AWS Lambda, lets developers deploy JavaScript functions that scale automatically without managing servers. AI-assisted tools are also changing how JavaScript is written, helping developers work faster and more efficiently. JavaScript has grown from a small scripting tool into a universal technology that powers web, mobile, desktop, cloud, and AI applications. Its flexibility, strong community, and constant innovation ensure that it will remain a central part of the software world for many years ahead. Many leading companies now adopt full-stack JavaScript architectures using frameworks like Node.js on the server and libraries such as React or Vue.js on the front end, because a unified language across client and server simplifies development workflows and speeds delivery. This stack enables smaller, tightly coordinated teams to own whole features end-to-end, reducing handoffs, increasing developer productivity, and shortening time to market. On the performance front, modern JavaScript runtimes and asynchronous I/O models are well suited for many enterprise-scale applications. Today, JavaScript has become an indispensable component of software engineering, as an increasing number of applications are developed for online platforms and deployed as web or mobile applications. JavaScript remains one of the most widely used programming languages across the software stack and continues to evolve to meet modern development needs.